What if I tell you that at the end of 2021 you can see 13 billion years into the past and it has nothing to do with time machine? This is largest, most complex and challenging space telescope ever constructed. You are looking at the $10 billion telescope. James Webb Telescope is one of the most awaited projects. It had been delayed more than 15 times, but finally they decided to launch it at the end of 2021. And if everything goes right, we will see the launch of this engineering marvel at the end of this year. It will take us on a journey to the edge of the universe and reveal us the first formation of galaxy, and most importantly, it will change our understanding of the cosmos and our place in it. But why do we need another telescope? Don't we already have many? So why another one? And why people are spending so much amount of money and time into this particular project? I will answer all of these questions. But before we move ahead, make sure to subscribe to my channel and press the bell icon so you don't miss any future update. When we look up at the skies, we see stars, galaxies, nebulae, and the Milky Way. What we can see with naked eyes is a very narrow part of the region, but mysteries of the universe lies in a different region. And when you turn the switch on, you can see the real beauty of the cosmos. The electromagnetic waves that we receive from distant stars and galaxies make up the most important way to study the cosmos. So the question is, if our eyes cannot see the entire spectrum, how can we explore the vastness of the universe? Well, that's where the advanced telescope comes into play. We have launched many telescopes that work in a different region of the spectrum, and one of them is Hubble Space Telescope. It already changed the way we look at the universe. Since its launch in 1990, it has provided a dazzling array of images that have awed and inspired the public. More than just pretty pictures, the dozens of terabytes of data collection has provided insight into the universe, from objects as close as the moon to the most remote galaxies, with incredible photos of supernova and nebulae in between. So why do we need James Webb? Well, what Hubble studies was primarily at the optical and ultraviolet wavelengths, but when it's come to the Webb, it's an infrared observatory. This means the Webb will help us to observe even those distant areas that were out of Hubble's reach. That means more amazing stuff. But how can an infrared telescope offer a deeper insight into the universe's past than an optical one? The universe is full of regions that contain dust. Stars and planets that have just started forming also lie behind the cocoon of dust. Even when you look at the Milky Way, you will notice dark dust clouds hide much of the galaxy. The problem is, this dust absorbs most of the visible light due to its short wavelength. This is what's stopping us to take the deep insight into the hidden region. But as we know, infrared rays have longer wavelength than visible rays. Hence, infrared can easily penetrate the dusty cloud to reach us. James Webb Telescope will provide wavelength coverage from 0.6 to 28 micrometers. This will help Webb look over 13 billion years back in time, thereby providing images of first galaxies formed and observing unexplored planets around distant stars. You might be wondering why I said back in time. It's not a time machine, although that would be nice. But it's just a telescope. And how can telescope look back in time? It all has to do with this guy. Einstein said that speed of light is constant and nothing goes faster than speed of light. Because of the time it takes light to travel, the farther an object is, the farther back in time we are looking. Sunlight takes 499 seconds to reach Earth. That means the sun we see is how it looked 499 seconds or 8 minutes and 19 seconds ago. That's how everything we see in the sky is how it was in the past. James Webb is an orbiting infrared observatory that will investigate the thermal radiation of space objects. When we hit solid or liquid, after a certain temperature, they will emit energy in the infrared spectrum, and that's what Webb is looking for. The very important quality of this telescope is that it will revolve around the sun, not the Earth like Hubble. Webb also has a much bigger mirror than Hubble. This larger light collecting area means that Webb can peer farther back into time than Hubble is capable of doing. Hubble is in a very close orbit around Earth. Webb is on the other hand will be 1.5 million kilometers away at the second Lagrange point. Hubble is in Earth orbit. It was able to be launched into space by the space shuttle. Webb will be launched on an Ariane 5 rocket, and because it won't be in Earth orbit, it is not designed to be serviced by the space shuttle. So why they choose second Lagrange point? At the L2 point, Webb's solar shield will block the light from the sun, earth and moon. This will help Webb stay cool, which is very important for an infrared telescope. However, Webb will move in sync with Earth to maintain strong communication. Webb will have an approximately 6.5 meter diameter primary mirror, which would give it a significantly larger collecting area than the mirror available on the current generation of space telescopes. Hubble's mirror is much smaller, 2.5 meters in diameter, and its corresponding collecting area is 4.5 meters square, giving Webb around 6.25 times more collecting area. Webb will have significantly larger field of view than the NICMOS camera on Hubble, covering more than 15 times the area. and significantly better spatial resolution than is available with the Infrared Spitzer Space Telescope. Launching such a telescope into the space is an incredible engineering challenge. Fully deployed Webb is too large to fit inside any rocket. So engineers all around the world design it to be folded like origami to squeeze inside the European Space Agency's 5-meter diameter Ariane 5 rocket fairing. After launch, controller on the ground deploy Webb remotely. Deployment is an intricate process. For nearly 3 weeks, controller unfold Webb. After this delicate dance, Webb's golden mirror are precisely aligned using motors behind each hexagonal mirror segment, adjusting them to form one perfect mirror. Once the instruments are cooled, the exploration will begin. It's an effort of thousands of engineers and scientists across the United States, Canada, and Europe. If everything goes right, it will allow us to see more of the universe and in greater details than ever before. And perhaps it will even usher in a new age of knowledge and enlightenment. This could even cross off one of our greatest unknowns by discovering alien life. Peace.